Hi, so this is our final lesson on the Forces and Motion playlist. So we're going to look at pulleys. And we'll begin with question 1, where we're told that a particle of mass 5 kilograms rests on a smooth horizontal table. This is the particle here, and because it's smooth, we can assume that there's no opposing friction. It is connected by a light inextensible string, which is this string here. Because it's inextensible, we can assume that it does not stretch or compress, and it passes over a smooth pulley. So again, there's no friction over this pulley. And this is at the edge of the table, and it's connected to a particle of mass 2 kilograms. The particle is hanging freely. So we've been asked to work out the acceleration of the system. So the first thing we need to do is to add on any forces. So I'll draw a quick sketch. So to find the acceleration, the first thing we need to do is to add on any forces. So I'll draw a quick sketch. Okay, so we know that the string is light and inextensible, so there will be a tension acting in this direction from the box or particle of mass 5, minus T. And because it's light and inextensible, this will be the same as the tension in this cable acting in the opposite direction. So we'll call this T. And there will be a downward force on the 2 kilogram mass, which is 2G. And because it's a smooth surface, there's no resistance force acting in this direction. And I'm going to call this A and this B. So now I'm going to consider A and B separately. So we'll begin with A. Because the system is moving downwards, we know there's an acceleration acting in this direction. Then the box will be moving towards the pulley. So this tension will be equal to the mass of a particle A times the acceleration. And we'll call this equation 1. If we now consider particle B, and we resolve this downwards, then we know that 2G minus the opposing tension will be equal to the resultant force of the mass, which is 2, times the acceleration. And we'll call this equation 2. So because we have two equations with two unknowns, we can use simultaneous equations. So for equation 1, we have T minus 5A is equal to 0. And for equation 2, we have T plus 2A is equal to 2G. We know G is 9.8, so this will be 19.6. And this is equation 2. So I'm going to solve these using the function on my calculator. So the first thing we'll do is we'll change the mode to solve simultaneous equations. We have the first variable T with a coefficient of 1. The next variable A is -5, and this has a value of 0. For the next equation, again the coefficient of T is 1. The coefficient of A is now 2, and the solution of the constant is 19.6. So we can see that T is 14 newtons, and A is 2.8 meters per second squared. Okay, let's try example 2. Okay, so in example 2, we're told that we have a light inextensible string that passes over a fixed smooth pulley, and particles of masses 3 kilograms and 2 kilograms are attached at opposite ends of the string, and each part of the string hangs vertically. So for question A, we've been asked to explain whether tensions in the strings are equal. So this is these tensions equal. So the tensions are equal because the string passes over a smooth fixed pulley. So if we had resistance acting one way or another, these tensions would not be equal. So for part B, Explain where the acceleration of both particles are equal. So the accelerations are equal as the string is inextensible. So if this string has some stretch in it, then this particle would move at a different acceleration compared to this one. So for part C, find the acceleration of the particles. So now we need to consider each of the orange and the green masses. So I'll label this one as A, and the green one we'll label as B. So we're going to consider mass A first. Because the acceleration is acting downwards, the 3g, the weight, will be greater than the opposing tension. So 3g minus the tension will have a resultant force of a mass times the acceleration. And we'll call this equation 1. Now we can consider mass B. And because this is heavier, this downwards motion must move B upwards at the same acceleration. So now the tension is greater than the weight. So T minus 2g will have the same, will have a mass of 2, but the same acceleration of A. And we'll call this equation 2. So again, we've got a pair of simultaneous equations. So for equation 1, we've got tension plus for 3A is equal to 3g. And for equation 2, we've got the tension minus 2A is equal to 2g. And again, we can solve these in our scientific calculators. So we get the acceleration is g over 5, and this is meters per second squared. And the tension is 12g over 5 in newtons. So finally, for part B, find the force required to hold the pulley in equilibrium. So this means that the upward force is preventing this pulley from moving. So the acceleration of the pulley will be 0. So for part E, the force minus the tension on this side and the tension on this side, so the 2t's, so force minus 2t will equal 0 net force, or 0 acceleration times the mass. We know the tension is 12g over 5, which is this. So a force will equal 2t, which is 24g over 5 in newtons. Okay, so thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, missmathematics.com, and there's a link in the description below. Thanks again, and take care.